In this video, we are going to discuss about the design for testability. So, on completion of this topic, students will be able to reduce the high cost in time and effort required to generate the test vector sequences for VLC circuits. So the major agenda we are seeing here is importance of testing, what is testability, what is DFT sequence, manufacturing defects, fault modeling, and methods to test the transition fault equivalence, and structured approach. So what is the importance of testing? So mainly in VLSI design for testability is mainly used to make the digital circuits easier to test during the manufacturing and debugging process. So this DFT in VLSI design involves in incorporating additional circuitry and design features such as scan chains, built-in self-test circuits, and boundary scan cells into the chip design so that this facilitates the testing. This design for testability is mainly very essential for ensuring that the fabricated chips are free from any kind of manufacturing defects, and also it also reduces the overall test time, and thereby it reduces the cost of testing and debugging. So it becomes very easier to test the structural correctness of the chips and leading to the higher quality products and faster time to time market. And what is testability? So by designing this chip with the testability in mind, it becomes very easier to identify the structural defects in the chip and fix design errors before the product is shipped to the customers. So designing a chip with built-in testability features can make the testing process more efficient, thereby reduces the cost and time required for testing. So this can lead to the significant cost savings during the manufacturing process. Also, by incorporating this DFT features into the chip design, it can help to identify any defects early in the process, which allows for faster repairs and improvements in production yield. Also, this design for testability can help in accelerate the development cycle, and also by reducing the time and effort required for testing and debugging. So this DFT can make it easier to diagnose and fix the problems in the chip design, which reduces the effort required for maintenance and updates. This is very controllable and observable. So what is DFT? So DFT refers to the hardware design styles or added hardware that reduces the test generation complexity, which has the motivation of it increasing the complexity. The generation complexity increases exponentially with the size of the circuit. Also, this enables the manufacturing test. So it is a structural technique which facilitates the design to become testable after production. So why we are going to DFT means to increase the productivity and to improve the quality. So in the case of the productivity, there is shorter time, reduced design cycle, reduced cost, and also in the case of the quality, it reduced defects per million, improved quality of test. And in the case of DFT technique, it contains two techniques. One is ad hoc technique and structural technique. As the name implies, ad hoc, it is a temporary technique that we are using for enhancing the design testability without any change in the design style. Also, this good design practices are used for the guidelines of ad hoc DFT. And the structural technique, here we provide more systematic and automatic approach to enhance the design testability. So manufacturing defects, physical problems are extra metal causing shorts, insufficient doping, contamination causing opens, CMOS stuck on, CMOS stuck open, slow transistors. The major thing in the defect is the term defect generally refers to the physical imperfection in the processed wafer. Sometimes these defects are observable through the optimal medium, or it cannot be visible also. And the fault is representation of the defects can be abstracted at a level which we call as fault. Error is a wrong output signal produced by the defective system. Failure is the repeated occurrence of the same defects, indicates the need of improvements in the manufacturing process. Also, this can be found by any causes. And fault modeling, due to the defect during manufacturing of the integrated circuit, there is a possible of fabrication process, that is stuck at fault, transition fault. So stuck fault is from the beginning of the DFT. Single stuck fault is the most popular fault model which we used in the imperfection lithography. So these examples are fault activation, propagation, and line justification. And D algorithm, this is the major thing that we are used for targeting the specific stuck fault. Also, this is opposite to the value. Here it provides a propagation error at every primary output. It generates the patterns from one stuck fault at a time and also involve the decision making. So transition fault model, this is similar to the stuck fault in many aspects. The major effect is rising or falling transition at the P will not reach an observable output such as scan flip-flop or primary output. So the methods to test the transition fault is delayed test requires a vector path to detect a fault. Also, these patterns must be applied at the rated speed at speed testing is needed. So here several methods we are using for producing the speed transitions which can detect either the faults also. So there are two methods to detect the transition faults. One is Q load or launch from shift. Next one is Q load or launch from shift. So that is that we are writing as the fault equivalence. The gates begins in the same way from the SA0 or SA1 or the outputs at the SA0 and SA1. So here mostly the faults are identified during the testing process. So when there is some collision or there is any changes occurs, it can be automatically identified, which we call as equivalent fault or primary faults. Fault coverage is calculated using detective faults divided by total number of faults. Test coverage is total number of detective faults divided by total number of detected faults. And the structured approaches tries to boost up the overall testability. So this testability is mainly designed in each time, which is manually done, which is automatically done by the controllability and observability. So this design in three modes, that is normal mode, shift mode, and capture mode. So scan scale designs are mixed decels and clocked decels. Why we need for scan designs is this is used this can be well understood by considering by an example, that is mainly if we transmit any information, this should be automatically tested so that so that there will not be any complexity or there will not be any error inside the fault models. So this tries to be an externally accessible by connecting the scan inputs to a primary input and the output. So this design is most popularly structured. It is implemented by connecting the selector storage elements present in the design. Quiz questions on design for testability. The functions performed during chip testing are detect faults in fabrication, detect faults in design, failures in functionality, all of the mentioned. Thank you.